Greetings to all. As a part of our assignment, me, Dhoni Upadhyay, and my teammate Prashasti Srivastav will be describing the RTP and RTSP protocols briefly and simulate real time video streaming between server and client and discuss the code used for it. So, what is the RTSP protocol? RTSP stands for Real Time Streaming Protocol. It is an application level protocol that helps with real time data transport by establishing and controlling the media stream between client devices and servers. It is a network remote control for time synchronized continuous streaming media such as audio and video. It does not stream the multimedia itself but instead interacts with the server that does. The multimedia data is often transmitted via lower level protocols such as RTP rather than the RTSP connections. Its functionality and syntax are similar to HTTP, making it easily interoperable with current HTTP networks. Through these approaches, the RTSP protocol provides a variety of services and operations. A describe request contains a URL and explains the replay data. A setup request specifies how to deliver the bit stream. A teardown request terminates the streaming media session. The play request requests the server to stream data to the stream allocated via the setup service. And the pause request causes the supplied media to be frozen until the user pushes the play button.
Now, talking about the RTP protocol, also known as real time transfer protocol, which is used to handle the real time traffic to transfer the network packets of media like video and audio. It is used with the UDP or the user datagram protocol, a communication protocol used across the internet for especially time sensitive transmissions such as that of video playback or of DNS lookups. The transport protocol is now responsible for flow control. Also, one of the biggest advantages of it is that packets are sequence numbered and time stamped for reassembly if they arrive out of order. This compensates for the disadvantage of UTP protocol as it doesn't guarantee ordering or even guarantee delivery at all. The best way to understand how the components, as mentioned earlier, work together to provide an audio video stream is through an example. Let us understand it by this diagram. The basic steps in this process would be that the client establishes a TCP connection to the server first, typically on TCP port 554, a well-known port for RTSP. But here we have used another port. The client then issues a series of RTSP header commands where the client describes details of its session requirements, such as supported RTSP version, transport used for data flow, and associated UDP or TCP port information. This information is passed through describe and setup headers. This is appended to the server response with session ID that clients and temporary proxy devices can use to identify the stream in subsequent exchanges. Once the transport parameters have been negotiated, the client issues her play command to tell the server to start delivering the RTP data stream. When the client closes the stream, her tear down command is used with the session ID, telling the server to stop delivering her RTP associated with that ID. And this is a basic model of a client server for RTSP and RTP protocol implementation. Now let us see our code. Here is the first, the server. The server class here enables the server and binds the server port to the socket used for data transmission. The argument given here is the port number decided by the user. Here the listen function indicates that 5 maximum clients can bind to the server at one time. The accept function returns a tuple where the first object is the new socket object and the other argument is the address bound to the socket. The infinite loop accepts the client request and runs accordingly. This is the server worker file now. There are several variables which we have initialized at our convenience. The integers indicate the state of the video, and the state variable describes the present state of the streaming video. The client info is a dictionary which stores the information required for each client and is initialized. And the thread function here creates a separate thread for each client. This is the receive RTSP request, and it receives RTSP request from the client info dictionary, and then processes it accordingly. Now, the next function is the process RTSP request, and this function sets the whole video. There are four methods mainly, which are setup, play, pause, and tear down, which we would define under this function. It receives the request type on the basis of which the method is processed, media name, and the sequence number essential to establish the RTP protocol. For the let's look at each request. The this is the process. This is the setup request, and if the state is already in init, then it would update to ready state. After this, RTSP would generate a random ID here with the random function for the request and reply affirmatively. Now this is the play request, and if the server state is already ready, then it would be updated to playing state. A socket is created here by the RTP protocol for streaming of data, and then the server replies to the RTSP request of the client. Afterwards, a thread is created for sending of the data to the client as shown here. Similarly, for the pause method, the state is updated to ready state if it is already playing, and the event is set accordingly for the player. This is the tear down request, and it simply closes the RTP port and terminates the thread irrespective of the previous state, ultimately closing the connection. The send RTP function returns packet, which are in turn made by calling the RTP packet class. These instructions are executed in an infinite loop, and the loop breaks only when the user requests pause or tear down. The reply RTSP function is used to send a customized message to the client for every reply sent to the server. The next is the RTP packet file, which where this class RTP packet has various functions used for packetizing the data. The encode function set all the header byte array having size 12 as declared here. Also, all the other function consists of only one or two line of code which are self-explanatory and does exactly what it describes here.
Now we will discuss the client launcher file. The client launcher accepts four arguments that are the host name, the IP address of the device or its name, the server port which we have already set in the server file, the RTP port again according to the user, and at last the file name of the media transmitted. Using the arguments, a new class of the client is created which carries all the weight in the client code. Main loop method in the main video executes what we wish to execute in an application, which loops forever until the user exits the window or waits for any events from the user. Now we will take a look at the client file. We declare the same variables with the respective values as we did in the server file, and the present state is set to init. In the init function, the required values are typecasted and set accordingly. The connect to server function is called upon, which creates an RTSP socket and connects to the server using its port and address. The create widget builds the graphic interface for the user on which the media is streamed, and the buttons interact with the user to call upon the methods. The buttons are setup, which sends the RTSP request, play and pause for the video streaming, and tear down, which closes the connection. The next four functions here call another function named send RTSP request. This function requests the server to call upon various methods if the request is valid, such as that of setup when in init state. It increases the sequence number and creates a different thread to receive request from server to client. The last request is recorded in this variable. Whereas, if the request is of play and the state is already ready, sequence is incremented, play request is sent to the server and is recorded. The same procedure is followed for the pause request as well as for the tear down request. For all other cases of request, no action is taken. The receive RTSP reply function receives RTSP replies from the server, and this data collected is then passed on to the parse RTSP reply function for further processing. Also, if the teardown process request is received, then the socket is closed. The parse RTSP reply function parses the replies obtained and then obtains corresponding sequence number and session ID. According to the given conditions, necessary changes are made to the state. If a setup request is sent, then an RTP port is opened with the help of Open RTP port function. This function sets time out of socket to zero point 0.5 seconds and binds the socket to the RTP port, whereas the handler here displays the message box at the time of cancellation for confirmation and resumes streaming if declined. The update movie here configures the images and sets them such that they become the video frame with the help of the write frame function. Here that in a cache file of image distinguished by the session ID writes data to it in binary format. The listen RTP function in an infinite loop continuously listens for RTP packets, decodes them, and closes the socket after acknowledging the tear down request. Now we will take a look at the videostream.py file. The file to be watched is open in the red binary format and the frame number is initialized to 0. To get the next frame, it reads the first 5 bytes. To get the frame length, reads the rest of the bytes and stores it and then increments the frame number by 1. The last function simply returns the present frame number. Now we'll take a look at real-time simulation of real-time video streaming.
Now let us look at a demonstration of our code. Using the command prompt, we are going to launch a server file first of all. Here as an argument, we are giving the port number which is random and given by the user. Our server has started. Now we are going to launch the client. In this client launcher file, the first argument is the name of the device which we are using. The second argument is the port number which we have already given to the server. The next argument is the RTP port, which is again a randomly generated number, and the last argument is the file which we would be streaming. The file has started. We have set up the file. Now we are playing it. Now, if we pause the file, it works quite efficiently, and we can also see the frames are stopping whenever we pause the file and again starting. This final tear down would close the our streaming site. So this was our code and our assignment for IT304. Thank you.